welcome to our program today. We have Basics of Masonry. Here is our description and learning objectives. There will be some residential discussion today, but it will mostly be new commercial construction. Continuing education, we have all ways for you to earn credit. We have MISL professional development hours and AIA LUHSW of 1.0. And if you're an ICC member, make sure that we have your number on hand. Our provider statement as required. Our giveaways today, we have 2 of the Masonry Basics books, very informational. You'll enjoy that for sure. There will be a little plastic box coming around if you put your card or name inside there, and we'll draw it at the end. Today, our program is sponsored by Spec Mix, and we have Aaron Politzik in the back. Aaron, thank you for sponsoring the refreshments and everything for us. We appreciate it. Yes. Spec Mix specializes in pre-blended mortar, grout, and silo solutions. Spec Mix collaborates with architects, engineers, and contractors of all types and sizes to create and implement project solutions. They are the official home of the Spec Mix Bricklayer 500 as well. Thank you again, Aaron. And today is co-sponsored by the St. Louis chapter of CCCA, St. Louis Building Health Committee. We appreciate them. And today's speaker is Steve Gantner. Steve is an executive vice president for Conspectus, Inc., a national consultancy. He is based in St. Louis, Missouri, and has more than 30 years' experience in all phases of construction, including programming and planning, budget review, design coordination, construction documentation, design team management, construction specifying, and contract administration in a wide variety of facility types. His specialty areas include design build, construction management, integrated project delivery, owner project requirements, documentation, project systems, and performance descriptions, procurement and construction specifications, quality assurance reviews, and is a Conspectus Cloud, which is an award-winning decision management tool expert and development contributor. Steve is passionate about education and collaboration between the specifier and the construction team and is available for classes and presentations. Please welcome Mr. Steve Gantner.
Thanks, Margaret. Thank you. Good morning, good afternoon. What time is it? Good noon. Can you guys hear me okay? Keeps flopping around. Anyway, like Margie said, my name is Steve Gantner. I work for Conspectus. I'm actually one of the owners of Conspectus. We have 3 owners, 3 partners. We are the nation's largest independent specifiers of construction materials, basically architecture. A little bit of my background, just for your information. I come from a masonry family. My dad was a bricklayer here, local 1. Did quite a bit of work in the area. He retired quite a few years ago. But before him, my grandfather was a bricklayer. Grew up in Ferguson, Missouri. His father was a bricklayer, and we've traced it all the way back to Pilot Grove, Missouri, where my great something or other was a brick manufacturer. So it comes naturally in our family, I guess. We like construction and we like masonry. Fortunately, or unfortunately, however you want to look at it, my dad threatened to break both my legs if I became a bricklayer. So I'm an architect. I am registered in the state of Missouri, and I've done quite a few projects in the area, but now I work worldwide, actually. I got projects going on all over the world right now. Let's keep going a little bit. We're going to talk about basics of masonry. I'm going to tell you the basics, right? That's concrete masonry units right there. Thank you. I'm going to go home. That was one bomb. All right, first let's get started with resources. There are quite a few resources for you out there on the internet. Quite a few of them I use frequently. The Brick Industry Association of America. They are gobrick.com. I highly recommend you look at that. I I remember a few years ago when Ed Glock came into the office, Ed and Daryl would come in bearing gifts. And it was a 3-ring binder about 3 inches thick, and it had all the BIA tech notes in it, and that was like gold. Loved looking through those, seeing the details and the information it gave you. NCMA, the National Concrete Masonry Association. Go there and find the NCMA tech notes. That has everything to do with concrete masonry units. The Go Brick is obviously clay units. The NCMA is concrete units. IMI.web. I've got a few slides in here that are details from IMI, the International Masonry Institute. Great organization. They're located up north near Chicago and over on the East Coast. And they're in affiliation with the International Bricklayers Union. They do a lot of good work, a lot of good details on their website, a lot of information. MasonContractors.org, the fine folks who bring this building to you, build all the buildings in the St. Louis area and across the United States. Oops, back up here a minute. The Masonry Society. A lot of what I'm going to talk about today is from the Masonry Society. They've got some free publications, but they also have publications you have to pay for, and a couple of them we'll talk about. And then right here, the Masonry Institute. You've got a wealth of information in this building. Call Greg, call Bruce, call Dave Gillett, call Margie. Talk to anybody, and they can help you out or at least point you in the right direction. Mason contractors also have a BIM library you can look at and borrow from. I checked it out a few weeks ago, and looks like you can register online and get a free 1-year subscription to it. I'm not sure what the cost is after that. I don't use BIM or anything like that. I design buildings with words now, but good information there. The other one is Cast Stone Institute. A lot of cast stone going on, a lot of sills and headers and things like that with cast stone. Indiana Limestone Institute. That used to be a popular giveaway here. They would give out books, copies of that book. Thin little book, but a lot of very valuable information in those books. We already talked about the Mason contractors. And then finally, the Natural Stone Institute. This has everything to do with whatever they take out of the ground. Now we're going to touch a little bit on codes, regulations, standards, a lot of the fun stuff. First off, we're going to start with TMS, the Masonry Society, 402-602. 402 is written for designers. It's how you're going to typically design your building, structural engineers, architects. You look up there, you get the information you need to design your building, strength of materials, things like that. I typically live in TMS 602 right now, which is the specifications. So we'll work a little bit heavier in the specs today. But both docs are referenced by both the IBC and they both refer to the ASTM standards for testing and methods, testing and materials. Now this threw me for a loop because I was not aware until I started doing research for this. The Masonry Society used to be on a 3-year code cycle with IBC. They would publish just before IBC published their stuff so they could be incorporated into the IBC. Just found out recently that the TMS has now gone to a 6-year cycle. So 2018 IBC refers to 16, same with the 21 IBC. But 2024's IBC references a 2022 Masonry Code. Masonry Society published that one. That has significant updates on it. If you're not coming next week, unfortunately I'm not going to be in town. I would love to come next week and hear what the new updates are, aside from what I'm going to talk to you about today. Bruce, if you have questions about that, you can talk to Bruce. He's kind of a little bit more knowledgeable in that than I am. Let's start a little bit about fire resistance ratings. So they're based on equivalent thickness. And what we mean by equivalent thickness is you see 2 types of blocks up here. You have an 8x8x16 and you have a 4x8x16. And when it comes to fire resistance, those 2 blocks have the same fire resistance rating to them, unless you were to do something to modify the hollow block. They both got about, well, I'll tell you exactly. An 8x8x16 has 3.8 inches of equivalent thickness, and the 4x4 has 3.6 inches. But with both of those blocks on the inside of a building, you get a 1.5 hour rated wall. Okay? So the TMS 216 helps you determine the fire resistance for CMUs. Likewise, they have a guide for sound transmission class, and they've got ways to calculate the sound transmission for the types of brick, if it's solid or hollow or special shapes. Masonry does a really good job of reflecting or absorbing the sound. The hollow units can be carved out and manufactured in such a way where they can absorb sound into them and bounce that sound inside the blocks. Or if you had a solid shell and you put a paint coating on top of it, it could reflect that sound very well as well. It's a new one. Move on a little bit to the building systems, building envelopes. A little bit of history. In the St. Louis area in the 1890s-ish, when we first became a city, a lot of the masonry here was solid masonry, meaning 2 or more wides of masonry, commonly brick. They'd have a face brick, and then they'd build in the middle, and then an interior brick, and they'd just fill it up with whatever they could find. If it wasn't clay, they could put stone in there. They'd fill it with grout, but it was a solid mass wall. Then a little bit later, in the 30s, or in the, sorry, back up a minute. Wanted to point out the fire cut. Whoops, wrong button. You see the fire cut right here, and the tie, and the star. You can see it over here. There you go, fire cut. They would cut the joist in, on the floor joist in, so that if the truss were to fail, it wouldn't bring the whole building down. The joist would fall into the building, the walls would still stand. The ties, on the other hand, helped hold the building together to keep that lateral pressure from forcing the walls out on 2 stories or more buildings. So they would tie those to the joists. And that's why a lot of the older buildings in St. Louis, you'll see with those stars on the outside. So in the 20s to the 50s-ish, we kind of transitioned and went to a structural clay masonry unit. And there's one up front, and on your way out today, take a look at it. It looks like a 9x9 core. It's standing up on its side. It just looks like a clay flue tile, but it's filled in the middle. They'd use that as a structural backup to a face brick of brick or stone. And then 1950s on, we've adjusted, and we've now moved into the anchored veneer masonry wall. It could be stone, it could be brick, it could be block. There's no limitations on what you can anchor to that structural backup. Just going to talk about 3 different basic types of wall envelopes right now. Mentioned the anchored wall system. Basically, it's the wall is tied to the back of the structure. Concrete masonry backup, you're talking a full single wide concrete masonry unit typically, backing up the veneer wall. That is tied, that can be tied with adhered or with anchored veneer. And then a lot of stuff nowadays is not wood backup, it's steel stud backup. You still have wood in residential, but the steel is primarily cold form metal framing in commercial buildings. So you see Premier Wall on here. I was talking to Dave Gillick about that. This is sort of an ideal wall. You can probably build this anywhere in the world and have a successful outcome with the codes, with energy codes, with just the general building itself. It consists of basically your CMU or stud wall backup, a sheathing layer, or in the case of concrete masonry unit, just the weather barrier directly applied to the masonry unit. And then you come back with your insulation on the outside of the cavity. You don't have to insulate the cavity itself or the block cores themselves. And it's actually probably better if you keep the insulation outboard. When we talk about energy code in a little bit, talk about where that dew point is supposed to occur. And we want that dew point to occur outside of the building, preferably on the outside of the vapor barrier. And then you have an airspace, and we'll talk about airspace minimums in a minute. And then you'll have your base veneer. And you see also here a mortar deflection device on the bottom. That one was the leader in the industry for quite a while, and now there's several manufacturers of a similar product. There's one of them's out front. You can see what that looks like. It's a key device, kind of keeps the mortar from falling down and clogging up the drainage vents and the weep vents in front. And that's a way for means and methods. We don't really get into it for architects, but if you specify that you know your cavity is going to be a little bit more clear because water will get in and down and out of your building. It's an example of one of the details on the IMI's website. I really like this detail because it tells you everything you need to know about a traditional full masonry wall. You've got your CMU backup wall. Number two, you come out a little bit front there, you've got your air barrier or weather barrier, could be a vapor barrier, depending on what you want to do. Then you've got your flashing 51 on that, and then your insulation comes outboard of that, your mortar diverter, and your masonry. But some key important points here is, and we'll touch on this, is a control joint right here. You've got a transition membrane, so you've got movement on that control joint. You want that joint to be able to move freely. And then likewise, here on the brick, we've got to honor that control joint in the back. We've got to bring that forward in an expansion joint, okay? So right here you can see they've got three brick high. We're allowing room for expansion of that brick when it comes to, when it needs it. And then your flashing comes down, comes just about out to the wall, but you have most of the times that's a stainless steel drip edge. It can be any metal, really. You gotta be careful of staining. Stainless steel is probably the most popular one to use. Copper used to be the way to do it, but copper, as we all know, has gone up in price and cost. And it's kind of changed out a little bit. Different types of exterior single wide construction. You've got your single, like it says, single wide, and you can insulate the cores with a post-installed insulation, spray polyurethane type insulation. They drill cores into the cells, and then they pump it in there until it comes out the top and bottom. Or you can buy, and you'll see a few of these up front, units that have the insulation built into the units. So that's another way to get insulation in your walls. Or I've seen it now where they would do a spray polyurethane coat on the interior of the building too. And that forms your, at 4 inches or more, that can be a vapor barrier as well. TMS, like I mentioned, 22 is major code rewrite. Talking about cavities, the maximum overall depth depends on the backing. When you're talking wood, you're limited. And there's a chart, we'll get to that chart in just a minute, but there's a minimum of a 1 inch drainage plane. You need 1 inch of space behind your base brick and your insulation, if you have insulation, or your backup material. That's the minimum. BIA recommends 2 inches of airspace. Mentioned it just a minute ago. Excess mortar. Mortar bridging between the back course and the front course. We don't want water to come down and find a way back into the building. We want water out of the building. 2 inches of insulation will get you the code minimum required insulation. That's 2 inch, generally polystyrene or polyisocyanurate. So just to let you know, wood light framing, corrugated 1 inch is a 1 inch maximum. The corrugated ties, have you seen those? They're about 4 to 6 inches long. They're corrugated and they got nails in them. They can nail them to wood. You bend them and you just put them in the brick coursing. The masons generally put those up as they're going along. You can use sheet metal on wood framing. There's a 4 inch maximum on that. And then you can also use adjustable ties for wood framing. We'll get into those types in a minute. Adjustable ties, you can go up to 6 inches of cavity. Remember, air is an insulator, so the more air you have, the better your insulating of the wall will be. It's minimal, but it's there. And then as far as cold form metal framing, concrete and clay concrete, adjustable and 6 inches maximum, generally speaking. Talking about insulation, mentioned the blocks earlier. An opaque wall, no windows, would require you to do a UV calculation. Make sure you get the right amount of dampening. You can do it in several ways. ComCheck is one of the ways you can do that. I believe it's been a while since I've used ComCheck. I think ComCheck is free or was free to use. And then there's energy software. A lot of mechanical engineers do building calculations for you because they've got to do that when they calculate their HVAC units. But they can help you with what your wall should be. Then the other part is thermal mass. On the bigger the wall, the thicker the wall, the better your thermal mass. It will hold the heat, it'll disperse the heat. The best analogy I have is the old cathedrals in Europe. If you've ever been to Italy or Germany or anything like that, you've seen the larger walls. In Chicago, I think the Monadnock building is a 6-foot thick brick wall. Those hold thermal mass, and you can tell that because in the summertime you can go into those older buildings and it's actually cool without air conditioning because it's releasing some of that. It's keeping the heat out. It's absorbing it into the outside face and dispersing it at night, and it's allowing a slow transmission through into the building. Now the fun part. I love components of a building. We're going to talk a lot about what goes into a building and how you would, I like to talk about specifications. Obviously, I'm a specifier. Mentioned briefly, that's the corrugated tie we're talking about. The one up here is an adjustable one. And this right here is wire reinforcing for single component wall, single wide wall. You lay that reinforcing in the wall, they put mortar on top of it, lay the next course on, and you've got two pintles, two eyes sticking out for the pintle of the adjustable anchor to slide into. The mason will drop that in as he's going up with his coursing. Using ladder reinforcing primarily in the St. Louis area. I was just asking Bruce earlier if he's seen much truss type being the triangular shape with the two wires in the St. Louis area. Not really, just particularly for inside non-fully grouted walls. That's because the ladder type reinforcing is much easier for the mason to install. It's easier to lift over the reinforcing steel and put down. You don't have to worry about the mason potentially cutting those wires, which would reduce their strength. The other two types that are up here are anchors that are adjustable, but this one is a single point of contact, gets screwed right into the wall, goes through the insulation. This little sleeve on here and this little headed washer keeps the tie from being overdriven and compressing the insulation. It's meant to go through the insulation. And then you've only got one point of contact for thermal transfer of that reinforcing anchor. The other one was developed similarly with the idea of minimizing the point of contact with the insulation board behind. So this one is, the intent is to push this into the insulation, drive a screw through it, and those 2 points in that V shape of that leg would go back and touch into the stud or the sheathing. Man, tough time with terminology today. This is one of the changes that I found in the TMS. So much easier now, instead of having to read all the information. If you have a copy of TMS, just go to table 13.2.2.3, and it tells you everything you need to know about how to, what type of anchor to use, what your minimum spacing is, and what you can do. So this first column is the framing backup material. This column here is the tie type, and this is the maximum distance allowed. And this is the recommendation on how to install that material. These are all prescriptive and based on the code. Likewise, you have the same thing. This is just a continuation of the table. It was too big to put on one slide, otherwise you guys wouldn't be able to see it. So it just continues down for cold form metal framing, adjustable for concrete, and then clay or concrete masonry. Anchors are also limiting height. You're limited on height. For a wood frame building, you can't go more than 30 feet high with the corrugated tie anchor. You have to go to something different. You have to be 30 feet maximum for the first angle, and then you can go another 30 feet and do another angle on a commercial type building to keep the building from moving back and forth. There is no limit for concrete masonry backup, as long as your structural engineer helps you account for that movement in the building. Talked about movement joints a minute ago, about honoring the joints in front of it. If you don't know, concrete will crack. No matter what we do with it, concrete will crack if you don't give it away to crack. So it's called a control joint. We want to control where that joint cracks. So ideally, you put a 3/8 inch joint in there. You use what they call a sash block. It's a flat-faced block with a notch in the middle. You can drop a divider in between it, PVC or neoprene or some material like that, that keeps air from blowing through it. But then you also put a backer rod and sealant in there. This one's just asphalt impregnated paper probably, because that concrete will continue to shrink as the building ages. On the flip side, you've got brick. Brick needs to expand. Brick is as small as it's going to be when it comes out of the kiln. Over the life of that brick, it's going to continue to grow. Is everyone familiar with bentonite, waterproofing? And the reason bentonite works so well, because when it gets wet, it swells. Well, clay is just a smaller version of bentonite. You're just drying it out so much. But it will continue to grow. And if you don't have enough expansion joints, it will compress the joint out, the joint material out. And that'll cause a problem. You should probably go back in, cut that out, cut the joint wider, put more in, and redo it. Joe, if I'm saying anything wrong, please say so. Key point, pun on terms here. This is called a key. When you're grouting reinforced concrete walls, you need to leave the grout down a little bit to form a keyway to keep the lateral movement. You want that grout to bond with the next course below it, and that allows that bond to happen. You can also find more information in the NCMA tech note that's noted below that. Some key things to look for here. This is our shelf angle up here. Fun fact for neon specifiers, that goes in 055000, miscellaneous metals. The mason will provide that sometimes. They'll install that when they're building their wall up because they want to build it up, put that on there. You have compressive material underneath it as that building moves and fluctuates. You'll need your reglet type material, flashing to come down. It's supported by the angle, comes out the wall, and then either bring it out the full face of the wall or have some sort of drip coming out of your wall. On the top of the walls, it's very important. And if you walk out the building today, you can look across the street. There's a prime example. I love it when it rains. You can see the building across the street has a problem with either their coping or the roof. You guys can be the judge of what you think it is. I think it's probably a leak in the coping, but the joint is leaking all the way down at about the roof line, where I think the roof line would be back there. So have your flashing at the head of the wall. And then those joints ideally would be sealed with a non-staining type of sealant to keep the water further out of that wall. Talk a little bit about flashing. Different types of flashing like we talked about. You've got your metal flashings. You got copper, stainless steel are the primary ones being used these days. If it's a building that is meant to last a while, you probably use copper. They'll probably pay for the copper, hospitals, government facilities, things like that. Item B over there, your flexible flashings. I had a different type of material there. That red sheet is a copper core, but it's got reinforcing fabric around it. That's a product by a manufacturer here in the United States. Most of them make that nowadays. The other one on the black with the release paper is an asphaltic type, and then you've got a self-adhering type stainless steel. Those are pretty good materials. Then on item C, I mentioned the support of the flashing. It's very important that you support your flashing, otherwise it will drip, form a drip inside your cavity. That's a bad thing. We don't want mortar or water gathering in our cavities. So you want to support that. So ideally you bring that material up to support the flashing, and then you've got no problems. Hard coat, fill it with grout, fill it with mortar, fill it with whatever you want. Pea gravel if you'd like. Item D, wherever we have flashing, we want to have end dams if we have a break in the insulation. So for example, let's just pretend for a minute that this starts the edge of a window. We're going to stop downward flow of the water. We don't want it to go behind the window. We want it to hit the end dam and come out of the wall. What happens on the side of the windows, we don't care. Just keep it going down. It's also an ideal place to put an expansion joint because wherever you have a difference in planes, you want to have an expansion joint in that face material. Or if it's masonry, control joint, concrete control joint, going all the way up. And then finally, we've got our face weeps. Weeps should be about every 16 inches on center, 24 inches, I believe, actually. You don't need them at the head of the joint unless you want to kind of get some circulation back there. You can put the same thing at the head. That'll allow hot air to rise up and get out of the wall. Not necessary, not code required, just a thought. Mention it, all interruptions. It's a door, a window, wherever it is, you need to stop the downward path of water, get that water out of the building. Weep should always be above grade. Never put a weep below grade. If there's a chance that grade will come up in the future, we really don't want to see brick below the grade, but you can put brick below grade, just make sure it's covered or waterproofed in some sort of way. Put a waterproofing agent on top. Flashing longevity. Match the building life expectancy. There's no reason to put copper in a strip mall because they'll probably tear it down in 15 years, right? Or they'll sell it and the person who buys it doesn't care. Make sure it's compatible too with your air and water vapor barrier, air and water barrier. On the previous slide, you had, I don't know if you noticed, I didn't point it out, there's a termination bar. So you run that flashing up the back side of the wall, use a termination bar, drive it into the weather barrier or the sheathing or the CMU, seal the top of that joint so that water can't get in behind it, and that helps divert the water out front too. UV sensitive flashings, there's not too many of those around anymore, but a few years ago they still had the plastics that if they were exposed to UV for quite a while became brittle. And you could walk up to it and just kind of flick it with your fingernail and it would just break apart. There's not too much of that around. There is a fad with architects, I'm not a fan of it. They want to cut off the flashing flush with the face of the wall. I highly discourage that. Masonry discourages that. We want to get the water out from the building. All you're doing by cutting it flush with the face of the wall is allowing that water to come out and just run down the face of the wall. Drip it out, get it away from the building. And I corrected myself here, 24 inches on center for your weep joints. And I don't think anyone's really using cotton wicking anymore. It used to be where they would put a tube in or a cotton rope wick or something like that. And those were good. They worked for the purposes, but now the materials have developed that mesh type material is so much better on a head joint. It's like having an open head joint, but without the bug problem. Because really what that does is keeps bugs from going into your building. And if you do a cavity control vent up top on your wall, use the same type of material. I wouldn't recommend leaving it open, otherwise you might have a bee's nest back there. So barrier wall or a drainage wall. Had this discussion a little bit ago. I really don't know the difference. It's a single wide masonry wall. I think what makes the difference is what you put on the face of it. If you're going to have a CMU, a decorative concrete masonry unit, split face block, something like that, depending on where you are, I recommend a graffiti resistant clear coat because you probably paid for a colored block. If not, you can paint that block too. Put a paint coating on there, something that will protect that. Anything hits it will just run right off of it. Otherwise, in my opinion, it's a drainage wall. And this is one type of drainage that they would put in an open cell. So these obviously are grouted. But if you have an open cell, put one of these in and it's got a little tongue that comes out and just allows the water to get out of that opening. Another detail from IMI. This one's a really good one too. I like this. Shows clearly how you can do a lost my place up here. There we go. Assume this is an 8-inch wall, 8-inch block on the base for drainage purposes where you're not grouting the cell. Put a 4-inch block. Take your flashing inside the building, bring it out, drip edge and sealant on your foundation, and you've got your ladder reinforcing, and then you can grout it full. That's a perfectly good wall. I don't see it too much. I see a lot of single wide, but not too much of this. Clay units are tested through ASTM C216 and C652. It depends on the voids in the brick itself. All bricks have voids in them because you got to put them in the kiln so that they dry equally. Otherwise, you'll get cracking in them. And the solid bricks are a different story, but they got a special way to do those. There's 3 different types of face brick. FBX is the most stringent, and FBA is the least stringent. It depends on what you do. In masonry veneers, it really doesn't matter what type of brick you use. And that's generally why we have the backup walls, things like that, because the designers want to use something that looks good, and they pick out the brick before they know what the type of brick is. Like it or not, that's the way it goes, and we live with it. You see much brick shapes? Brick shapes are kind of expensive, but if you've got a lot of them, and they can run through the kiln all at once, it's a good way to go. Instead of having the mason have to cut those, cutting block is a time-consuming and expensive procedure, and it's also not safe for the mason sometimes because of the silica in the concrete masonry units. If they don't use the proper protective equipment, the masons can ingest that. It's just not good for them. Masonry units, ASTM C90. C90 in itself specifies a minimum 2,000 PSI. So you know no matter what block you're getting out of local plant, it's 2,000 PSI. And I think Bruce helped me out. It was the minimum compressive strength of a block coming out of St. Louis right now is about 4,500. Normal weight's 4,500. Okay. So you don't have to worry about that. Your normal weight concrete block coming out of Midwest block, our Ranieri is 4,500 pounds. Many different types of configurations. I mentioned a sash block before. This is an example of a sash block. That little joint in there allows for a T-shape or a plus-shaped material to keep the joints aligned. What allows you to put your joint backer rod and sealant in there. Your insulation types. I highly recommend you stop out front and look at the different types of blocks that have been dropped off here. It's fun to look at. But then again, I'm kind of a masonry geek. Other types of materials that we can use. Natural stone, glass block. There's some great examples of glass block in the conference room. They built the rotunda or the round wall, curved wall out of it. Cast stone. There's no cast stone on this building. Dennis Benke over there and I worked on this building when we were with the same firm. Adhered veneer. And adhered veneer, I got to tell you, I didn't even think about this until Dennis showed up today. This is an adhered veneer wall, traditionally adhered veneer wall. It's an 8-inch CMU wall behind it with your insulation, your cavity, and your brick outside. Inside, John Smith did the masonry on this building. John Smith put up wire lath. They came in with a mortar parge coat, a mortar adhesive coat, stuck the stone on there, and this is an adhered veneer wall. Did a great job on this wall, by the way. And then there are different types of materials. Fly ash. They also make autoclaved aerated concrete. I think that's in the code now. Not much use for that one. That was popular a while ago, but I don't know if it's coming back or not. I haven't seen much of it recently. Brick modules, 3/8 of an inch. Add it to any dimension on a brick, and you will get an 8-inch long brick. Generally 2 1/4 inches high, 3/8 inch joint is flexible. But if you stack a brick and a joint 3 high, you'll get 8 inches. Concrete masonry unit on the flip side is 8-inch or 7 5/8 inches. Add the 3/8 inch all around, and you get an 8x8 by 16 or 4x8 by 16. The key is keeping it modular, 4/8, 4/8. So that you can stack, for instance, I believe this is 8 inches here. That would be a CMU, and then 3 brick would also do it. So if you're driving by, for the younger folks here, it's how, when I was a young architect, they'd send me out to measure a building, and how are you going to measure a 20-foot tall building without a ladder? You count bricks, and just every 3 is 8. Just multiply it at the end of the count, and you got a rough idea. Helps everyone lay everything out. Helps you put your windows in. Unit dimensions on the windows are easier. Back here we've got a drywall partition or gypboard partition with a 2-inch head on the door jambs. If you're doing a full masonry wall, you probably do a 4-inch head because it courses out with the CMU. Get into mortar a little bit, and didn't know you guys were sponsoring. This is, don't tell AIA, this was already there before I knew they were here. Portland lime and cement. So when I was growing up, my dad was doing side jobs. I was the laborer on the job site. It came to me. So Dad would say, I need a 116. Okay, run that by me again, Dad. 116. It was typical type N proportion mix. 1 bag of cement, 1 bag of lime, 6 shovelfuls of sand, full heaping shovelfuls. And then you'd mix it for 4 or 5 minutes. Thankfully, companies like our sponsor today have come about and have these silos now on site. They bring them in big bags, pre-mixed. We don't have to worry about it. As designers, as structural engineers, you don't have to worry about the compressive strength of your mortar. They've already tested it. They've got the lab results to back it up, and it comes out perfect every batch. And I believe they can even color match anything you want in the factory and bring it out to the job site. But that's for them to talk to you later. ASTM C270 establishes the field recipe. Easy way to remember this. This is from Daryl. Daryl taught me this. N is normal, S is structural, and O is old. If you see a type O mortar specified, it's probably for an interior wall. It's pretty much a lime cement, a lime paste that they use to put up the wall. If you see masonry demonstrations inside of a convention center, things like that, they're probably using type O mortar because the type O can be easily taken down, disposed of, and cleaned up. You don't have to worry about the bond of it to the concrete floor. And then C270 also limits the amount of colorant you can put in the concrete. I'm not sure how that works, but there are certain colors that affect the strength of the masonry. Interesting question came up from a client the other day because they know that you're not supposed to re-wet concrete. You know, when the concrete truck pulls up and it's big old spinning drums up there and the guy's just dumping water in because he can't shovel it in fast enough. Well, mortar is the opposite of concrete. You can put as much water in as you want. Don't advise that. Generally speaking, the mason on the wall laying the brick or block will tell you how thick they want that mortar to be because it's workability. They want to be able to spread it on that brick and lay it in there as fast as they can. And if you've ever seen a mason work, it's amazing. I highly recommend it. Don't let the robots take over that job. Those guys were fantastic at what they did. I was telling Margie earlier, it was fun. When I was growing up, I never understood why my dad's bread looked like it did when he buttered his toast. But he buttered his toast like he laid brick. Who knew? So, and what happens too is they'll go to lunch. They got a half-an-hour lunch. They'll go to lunch. They'll come back after lunch. Mortar's still on the board. Just throw a little water on it, mix it up a little bit, and they can use it. So you can retemper that as much as you want. Brick, we want full bed and head joints. Partials of anything in this area are bad, even on veneers. It's pretty to look at. We still want full head and bed joints. On CMUs, we want full face shell bedding. Just some information for you. Okay, and this is usually the part as an architect, my eyes would just go F prime M. I don't care. It's basically the overall strength of the masonry unit wall itself, okay? So what it says here, unit strength method, 2,000 PSI is common. It's the minimum C90s coming out now. We're getting 4,500s. If you're greater than 3,000 PSI on your F prime M, that bad set of words, you need to do a prism test on that unit. Make sure that all works together to come out with that final 3,000 PSI. Fortunately, TMS made it easy on you. And I didn't know this until yesterday, thanks to Dave Gillick. There's a chart in the TMS code now that says, or in the spec, the net area compressive strength. So if you specify the F prime M for what that wall is supposed to be, there's your guide right there. You don't need to go any further than that. Grout materials, likewise. Looking at the grout, Match the compressive strength of your block. Easy as that. You got 4,500 pound block, but you only need 3,000, specify 3,000. But if you just specify 4,500, then you're good. So grout comes in different ways. High slump, it's a high slump, and you can have coarse or fine aggregates depending on what you're doing. If you're grouting a 4-inch CMU wall, keep in mind that that core is going to be very small, and you're probably putting a number 5 bar in there. So you got a little bit of area you got to fill in with the grout, and you got to vibrate that in there. So you want a fine sand-only grout. You just dump that in the wall. If you got an 8-inch block and you got a lot of room, you can use a coarse grout. Bigger rocks, bigger aggregate. It can be pumped or hand placed. Here comes some interesting facts here. Pours over 64 inches have to have cleanouts. What's a cleanout? Well, down at the very bottom of the wall, the mason cuts a hole in the block, similar to what we got here. And actually, I'm not even sure. Knock this out. If this was the face, knock that out, cut it out. That's a place where you can just pull all the mortar droppings from inside, because you can't prevent mortar from falling down inside the core when you're building the wall up. It's impossible. So you got to clean out the bottom of it so that you can see that the grout's getting all the way to the bottom. Vibration is only required for pores of less than, or vibration is required for more than 12-inch pores. So what does that mean? If you're not hand pouring it, you got to vibrate the wall. Reinforcing bars, I always specify them. I think it helps the mason. I haven't heard otherwise. It can be left out. They're probably a penny a piece when they put them in a big building. But it just helps make sure that that reinforcing steel is centered in the wall when you're laying up the wall. And I mentioned the key earlier. 1.5-inch grout key from block to block. Tooling. Very important tooling. The reason we tool joints is to make sure that that mortar is compressed. You just don't want a flush joint, because that flush joint, if you just think of, if you cut a piece of styrofoam, you can still see the core of that styrofoam. Well, you can still see the pores of the mortar. So you want to compress that a little bit. So either, two examples here are a concave or a V joint. Another one you can do is a weathered joint. And basically a weathered joint is a struck joint from the bottom of the brick. They just take a small trowel and knock off like a 90 or 60 degree angle, knock off the mortar on the front. So if water comes down, it just drains down and out. Very important. Don't ever do this. This is a tuck pointing job waiting to happen. Moving on to anchor bolts. Anchor bolts are important when you're building foundation walls or when you're supporting a structure on top of it. You got bar joists coming in, you got to put a metal plate or a metal anchor to weld to. Different types of anchors you can embed. Basically just stick them in, they grout it, stick it in there, and it stays. Epoxy and expansion anchors are two different types. You can do post-installed. Epoxy, you drill it out, blow out the hole, take an epoxy, mix it up, put the reinforcing anchor in there, drop it in, and let it set up. Expansion the same way, except you just tighten the nut down, and it expands and it holds itself in place. Be careful though your firewalls. If you're doing a firewall, what's the melting temperature of that anchor you're putting in there? Because you don't want to lessen your structure by compromising on that steel strength. Field tolerances, check out TMS 602. Masonry has some of the tightest tolerances in the industry. Steel, less so. So if you're going with a steel backup and you've got a masonry veneer or masonry infill, keep in mind that your tolerances are off. You want to make sure that you can match up to that. And then ideally, mock-up panels, sample panels, testing of those panels if you've got windows and stuff like that. In this instance here, I think this is just a sample panel for the architect and owner to approve the final construction materials. They want to see what it looks like. They want to see what it looks like clean. Touching on hot and cold weather masonry. A lot has changed in a while. If you see masons working and it's below, if it's 40 degrees or going lower, they're probably thinking about stopping for the day. The rule of thumb is generally if it's not going to hit 40 degrees during the day, you don't work. If it gets above 90, then it's questionable whether or not you work. OSHA has more to say about that than we do now. But I do recall several days in the wintertime when Dad was home from work because it was snowing. And that's just the nature of masonry. You got to be careful. Now, there are ways to around that. You can tent in the scaffolding. You can build in the wintertime by heating that scaffolding up. That's an expensive proposition. But if you've got to go through and get your building done, that's one way to do it. But coordination is key there. And there are special inspections required if you're going to be doing that. Masonry bracing. I don't really get into masonry bracing. I just wanted to mention it here because of the code officials, because you'll be looking at it. There are prescriptions for it. Check out TMS 602 3.3E. This falls under, for most architects in the room, they're not going to comment on this. This is means and methods. This is safety during construction. If they comment on it, they're going to get in trouble. But as for code officials, I highly recommend taking a look at this because you guys can have some sort of a say if it doesn't look right to you. Cleaning new masonry. We're heading into the home course here. Typically, it's 7 to 10 delays. 10 to 10 days delay. We want to let the mortar harden up enough. Okay. In the old days, they would just take a bucket of water, mix in some uric acid with some water, get a brush, scrub the wall, hose it off. That's really not recommended anymore. There are companies out there, Euclid, Proseco, several others that make chemicals that clean buildings and do a very good job of it. Use those to clean your buildings now. Problem with that is you don't know if you're going from top down or bottom up. You got to check with the manufacturer, make sure you're doing it the right way. Generally, you have to get the wall wet before you do it too, because that material could stain or soak into the brick. And what you do by pre-wetting it is you're making sure that that brick doesn't have the suction of that cleaning agent, which is sometimes a soap and a mild acid. Key is to protect your doors, windows, any other finished materials on the outside of the building you don't want damaged. Because they do have some acids in them, they could affect some of the other materials around your building. Likewise, on a windy day, you want to watch out for cars and where you park your cars. That sample panel I showed you earlier, it's a good place to test your cleaning agent. Make sure it cleans the way you want it. Recommend that they clean half of it and then they come back and clean the other half later. That way you can see what it looks like compared to the dirty wall, and then they come back and clean it up to make sure it's what you want in the end. And then there are specialty masons out there that do just cleaning. There are specialty masons out there that just do tuck pointing. They do joint sealants, things of that nature. And with that, I'm a little bit past my time. Oh, sorry, BIA and NCMA tech notes for cleaning. Take a look at those. And if you want to geek out, just read all of them. They're fun. So thank you to SpecMix. Appreciate you guys sponsoring this. Thanks for letting me talk. Does anyone have any questions?